Welcome back to the deep dive. Today feels a little different.
It does, doesn't it?
Yeah. Usually when we sit down to talk about, a software update or a new model release, we're talking about a tool getting sharper.
Right. Incremental improvements.
Exactly. It's 10% faster, or it writes slightly better poetry, or, the big one, the hallucination rate went down a few points.
All good things. Important things.
Of course. But they're incremental. They're nice, but they don't fundamentally change how you wake up and do your job in the morning.
No, we've spent the last, 3-4 years on a pretty linear trajectory of just building better chatbots.
Right. But this deep dive we've put together today,
Mm-hmm.
this feels like a break in the timeline, a real fork in the road.
Uh-huh.
We are looking at the release of Claude Opus 4.6, which dropped just a couple of weeks ago, February 5th, 2026.
That's right.
And just looking through the documentation, the benchmarks, the early user reports you've pulled together, I'm getting this distinct impression that the era of the chatbot is, well, it's officially over. It's over.
Yeah.
We're entering something else entirely.
I think colleague is the word we're looking for. Or, maybe even department.
That department.
Because you're right. The mental model for the last few years has been so transactional. You type into a box, the bot types back.
It's a ping pong match.
Ping pong match. Exactly. It's strictly serial. You ask, it answers, then you wait.
And if you stop typing, the bot stops thinking. Its brain just turns off.
Precisely. But Opus 4.6, this represents a shift from talking to a bot to managing a system.
Yeah.
And not just any system, but a team. We're going to talk about some features today, specifically these new agent teams and the 1 million token context window that just fundamentally changed the topology of work.
The topology of work. I like that.
We aren't just prompting anymore, we're orchestrating.
Orchestrating. Yeah, that sounds so much more executive than prompt engineering, doesn't it?
It's a different job description.
It really is. And we have a massive stack of notes here to get through. We have to unpack this 1 million token context window, which, it sounds impossibly large.
It's big.
We need to talk about agent teams, where multiple Claudes are apparently holding meetings without us.
They have their own Slack channel now.
It's wild. We have a case study about a C compiler that, honestly, it sounds fake, but we've verified it. And we need to talk about my new favorite term, vibe coding.
Vibe coding is going to be a fun one to unpack. It's a real thing.
It sounds like something that just shouldn't work, but apparently it does. But, okay, before we get to the sci-fi stuff, let's ground this. Let's start with the engine itself. Claude Opus 4.6. What is the headline spec that makes everything else possible?
The headline is scale, but specifically it's accessible scale. Opus 4.6 introduces a 1 million token context window.
1 million.
Which is currently in beta, but yeah, 1 million tokens.
Okay, let's stop right there. 1 million tokens. We hear these numbers thrown around all the time. 128K, 200K, now 1 million. In the AI world, numbers get so abstract so fast.
They do.
Help us visualize what 1 million tokens actually looks like. If I printed that out, what am I holding?
It's roughly 700,000 words. So to give you a physical representation, imagine you walk into a bookstore.
Okay.
You grab the entire Harry Potter series, all 7 books.
Wow.
Then you grab the entire Lord of the Rings trilogy, including The Hobbit.
Okay, that's a heavy stack already.
It is. Then, just for fun, you grab a couple of dense intro to physics college textbooks.
Yeah.
You stack them all up on a desk. That is 1 million tokens.
And I can just feed all of that into the prompt box at once.
In a single prompt.
Yeah.
You copy-paste, you hit enter, and the model holds all of that in its working memory simultaneously.
That's absurd. Thinking about the practical applications, I could theoretically upload my company's entire employee handbook, 10 years of financial records, a massive stack of regulatory filings, and maybe a whole repo of code.
Yep.
And just say, okay, based on all of this, what's our single biggest compliance risk for next quarter?
Theoretically, yes, but I do want to pause on that word theoretically.
Okay, the catch.
Because this is where the nuance is. Look, we've had large context windows before. Gemini 1.5 Pro, back in the day, it really pushed the boundaries. But we ran into this massive wall that the industry started calling the recall crisis.
The recall crisis, right. This is the phenomenon where the model, it forgets the stuff in the middle.
Exactly. Yeah. It's the lost in the middle phenomenon.
Yep.
If you gave an older model like Sonnet 4.5 or even the early GPT-4 variants a massive document, it would be great at remembering the first paragraph and the last paragraph. It had strong primacy and recency bias. But if you hit a specific fact, a needle, in the middle of those 700,000 words, the model would often just, well, it would blank out. Or worse, hallucinate an answer.
It's like when I try to read a really long book. I remember how it started and how it ended, but don't ask me about the details in chapter 14.
That is the perfect analogy. It's just information overload.
Mhm.
And for enterprise work, for that scenario you just described about checking regulatory filings, that's completely unacceptable.
No, you can't have a lawyer using a tool that misses 50% of the relevant case law just because it was on page 300 of a 600-page document.
It breaks the trust instantly. The whole value proposition just collapses.
So how bad was it? Do we have hard numbers on this recall crisis?
We do. There's a benchmark called needle in a haystack, specifically the multi-needle context retrieval V2, and it's brutal.
That's it.
They don't just hide one fact. They hide multiple, sometimes contradictory facts in a massive pile of unrelated text, and then they ask the AI to retrieve them and synthesize a conclusion.
Okay, so it's not just finding, it's reasoning.
It is. And on the difficult settings of this test, the previous generation, let's take Sonnet 4.5, specifically scored around 18.5%.
18.5%. Wait, that's not just bad. That's worse than random guessing.
It's effectively useless for any kind of high-stakes retrieval. It means you couldn't trust it. You would have to go back and double-check everything, which, it defeats the entire purpose of using AI to save time.
So as a party trick, look how much I can read, but not look how much I understand.
That's a great way to put it.
So the big reveal. Where does Opus 4.6 land on that same test?
Opus 4.6 on the same difficult settings scores 76%.
76. Wow.
Yep.
Okay, that is a qualitative shift. That's not an incremental improvement.
No.
That's going from I'm guessing to I'm pretty sure. That's the difference between a toy and a tool.
It's the difference between skimming and understanding. It means the model isn't just holding the data loosely in some kind of cache. It's maintaining the semantic connections between data points across that massive distance.
It sees the whole web of information.
Right. It allows for actual reasoning over very long horizons. But, and there's always a but, with this level of compute, maintaining that state is incredibly difficult and very expensive. Which brings us to a new architectural feature they've introduced called context compaction.
Context compaction. Okay, that sounds like a file compression tool, like zipping a folder or something.
It's a very similar idea, but for memory. Here's the problem. Even with 1 million tokens, if you're having a conversation that lasts for days, or if you have an agent running a complex workflow, you will eventually hit a wall.
You run out of room.
You'll run out of room, or just as bad, the sheer noise of the history starts to degrade the model's reasoning. It gets distracted by the irrelevant chatter from 3 hours ago.
Right, it's like trying to solve a complex math problem while someone is reading you a transcript of your lunch conversation from yesterday.
Exactly. The signal-to-noise ratio gets terrible. So context compaction is this background process. Instead of just chopping off the oldest memories when the limit is reached, which is the crude way we used to do it.
First in, first out.
Yeah, exactly. Opus 4.6 automatically analyzes the conversation history. It identifies the resolved threads, the dead ends, the low-value chatter, and it compresses them into a high-level summary.
So it's actively rewriting its own history book in real time.
Yes. It creates what they call a compaction block. It says, okay, the last 50 messages were us debating the color of a button. The final decision was blue. I don't need the debate anymore. I just need the outcome.
It preserves the decision, not the deliberation.
Precisely. It preserves the high-level architectural decisions, the why we made a choice, the goal we are chasing, but it discards the how we got there if it's no longer relevant to the current task. It prioritizes the reasoning capability over the transcript fidelity.
That is so smart. It's exactly like how our brains work. I don't remember every word of the meeting I had last Tuesday, but I remember the action items and the decision we reached.
Correct. It keeps the smart part of the AI active and focused. And without this feature, the next thing we need to discuss, agent teams, it would just fall apart.
Why is that?
Because those teams generate a massive amount of internal text, a kind of machine chatter that no human ever sees. Without compaction, they drown in their own notes.
Okay, yes. Let's get to the main event. Agent teams. This is the feature that every tech blog, every Twitter thread is screaming about. The sources describe this as a move from serial processing to parallel processing. Break that down for us. What does an agent team actually look like?
So up until now, working with an LLM has been a pretty lonely experience, right? It's you and the bot.
One-on-one.
One-on-one. Serial processing means you give a task. The AI does the task. You check it. You give the next task. It's a straight line, a single thread of execution.
Right. One thing at a time. Super tedious for complex projects.
Exactly. Agent teams completely changes the topology. Instead of one AI, you spin up what they call a lead agent. Think of this as your project manager or your direct interface.
So I talk to the boss.
You talk to the boss. You give the lead agent a high-level goal. Build me a mobile app that does X. That lead agent then has the authority to spin up multiple teammate agents to do the work.
So I'm not managing the individual workers anymore. I'm managing the manager.
Exactly. And the critical breakthrough here, the thing that makes this so different from the sub-agents we saw in early 2025, which were kind of clunky,
They were.
is that these teammates can message each other directly.
Wait, hold on. They talk to each other without me in the loop.
They have a shared task list and a mailbox system. They can essentially DM each other.
The AIs have Slack. That is both terrifying and amazing.
It's completely necessary for parallel work. Imagine a classic software development scenario. You want to build a new web app.
Okay.
In the old serial world, you'd ask the AI, okay, first, write the database schema. You wait. Then you take that schema and say, okay, now write the API endpoints based on this schema. You wait again. Then you take the API docs and say, okay, now build the front end to call these endpoints.
It's a long, slow dependency chain because the front end needs to know what the API looks like and the API needs to know what the database looks like.
Right, it's a bottleneck. But with agent teams, the lead agent hears, build a web app, and it spawns 3 workers simultaneously: a database agent, a back-end agent, and a front-end agent.
And they all start at once.
They all start at once, and the front-end agent can immediately message the back-end agent and say, hey, what is the JSON structure for the user profile going to look like? I need a draft so I can build the component. And the back-end agent replies, here's the draft. The final version might change slightly, but you can work with this for now. They coordinate.
So they are unblocking each other in real time.
Yes. They are simulating a human engineering team's daily stand-up meeting, but at the speed of silicon. It's happening hundreds of times a minute.
Okay, this sounds incredibly efficient in theory, but I have to be the skeptic here. Coordinating multiple AIs sounds like a recipe for absolute chaos.
Yeah.
I mean, getting human engineers to agree on an API structure is hard enough.
It's famously difficult.
Does this actually work? Or do you just end up with 3 agents hallucinating at each other in a circle, burning through my API credits?
That is the million-dollar question, isn't it? Is it coherent? And to answer that, we have to look at the big case study that Anthropic released with the launch. And it is, honestly, it's staggering.
This is the C compiler one.
This is the C compiler one. They tasked an agent team with writing a C compiler in the Rust programming language, completely from scratch.
Whoa, okay. Let's pause on that. A C compiler. That is not a Hello World website. That is not a simple script. That is deep, unforgiving, complex systems programming.
It's foundational.
Yeah. If you get a single memory allocation wrong, if you misinterpret one part of the C specification, the whole thing just explodes.
It's extremely difficult. It requires immense precision and a deep understanding of multiple complex domains. And they didn't just ask one Claude to do it. They spun up a team of 16 Claude agents.
16. A team of 16. That's a whole department. That's a small startup.
It is. And over the course of the project, these 16 agents engaged in nearly 2,000 separate work sessions.
2,000.
And in total, they wrote about 100,000 lines of production quality Rust code.
100,000 lines. But here's the part I don't get. If I have 16 people or 16 bots all editing the same code base at the same time, aren't they just going to constantly overwrite each other's work? How do you prevent what we call merge conflict hell?
That is the technical detail that impressed me the most. They didn't just talk to each other in that mailbox system. They implemented a file locking mechanism using Git.
They used Git, like Git check out a file.
Exactly like that. Just like a human engineer would go into Slack and say, hey, everyone, I'm working on the parser module. Nobody touch parser.rs until I'm done. The agents respected file locks.
Wow.
If Agent A was editing a file, Agent B would see it was locked, and it would either move to a different task on the shared task list, or it would just wait.
So they learn proper version control etiquette. That's a skill some junior human developers haven't even mastered.
They had to. Otherwise, as you said, it would be complete chaos. And the result, the final outcome, after all that work, it successfully compiled a bootable Linux 6.9 kernel.
It compiled a Linux kernel.
Okay.
And that is a benchmark that actually matters. That's not a poem about a cat. That is functional, critical global infrastructure.
It is the hello world of
Yeah.
systems programming, and it worked. But, and here's where I have to bring you back down to earth a little bit, we have to talk about the cost.
Right. I was kind of doing the mental math while you were speaking. 16 agents, 2,000 sessions, 100,000 lines of code. That sounds expensive.
It was. That single project cost approximately $20,000 in API credits.
$20,000
Yeah.
for one project.
Yeah.
That's the price of a decent used car. You're telling me companies are going to spend $20,000 to have an AI write a piece of software? That seems completely unsustainable for anyone but a giant corporation.
Is it, though? Let's play devil's advocate for a second.
Go for it.
If you had to hire a human team of senior systems engineers, real specialists who know Rust and the C specification intimately, to write a C compiler from scratch.
The very niche skill set.
Very niche. 100,000 lines of robust code. How long would that take them? 6 months? A year? Maybe more?
Oh, yeah, probably a year for a small, dedicated team to get it stable and working.
And what's the fully loaded cost of a senior systems engineer in Silicon Valley? $200,000, $300,000 a year.
Sure, easily.
So a team of 4 such engineers for a year is over $1 million. Suddenly, $20,000 and a few days of compute time looks like a 98% discount.
Okay, when you put it that way, it's an absolute bargain for the enterprise. But for the individual developer, for the hobbyist trying to build a cool side project.
For the hobbyist, it is completely out of reach. For now, this is an industrial-grade tool. And this leads to another technical distinction the sources mention: the difference between running these agents in in-process mode versus TMUX mode.
In-process versus TUM. Sounds like deep jargon. Translate for us.
So in-process is the faster, cheaper way to run these agents. They all share the same memory space. It's efficient, but if one agent crashes hard or starts to hallucinate wildly, it can pollute the memory of the others. It can bring the whole team down.
So in-process is like an open plan office. If one person starts shouting, everyone gets distracted.
Perfect analogy. And TMUX, mode named after a terminal tool that lets you split your screen, it isolates them. Each agent gets its own sandboxed environment, its own memory. It's safer.
So TMUX is like giving every agent their own private office with a lock on the door.
Exactly. It's more resilient, but it's also slower and more expensive because you're duplicating resources. And for that $20,000 compiler project, you can bet they were using full isolation to ensure safety, which drives up the cost.
Right.
But the power here isn't just in building new things from scratch, it's in fixing things. Have you heard of this concept of adversarial debugging?
Adversarial debugging. I have not, but it sounds intense.
Yeah.
Like you put the AIs in a boxing ring and make them fight it out.
That is basically what it is. Let's say you have a really nasty bug in your system, a race condition that only happens once every 1,000 times under heavy load. You have no idea what's causing it.
The worst kind of bug. The kind that makes you want to quit your job and become a farmer.
Right. In the old world, you, the human, have to form a hypothesis. You say, okay, I think it's the database connection pool. You spend 2 days investigating that. And if you're wrong, you just wasted 2 days.
And you're no closer to a solution.
Then you try, okay, maybe it's a network latency issue, another day gone. It's this slow, painful process of trial and error.
Yeah.
With agent teams, you can spawn 3 agents. You tell the lead agent, this bug has 3 possible causes. You assign Agent A to investigate and prove that it's the database. You assign Agent B to prove it's the network. And you assign Agent C to prove it's a memory leak in the application code.
So you force them to compete against each other.
You force them to debate and disprove each other's theories. They investigate simultaneously, in parallel. They present their findings to the lead agent. If Agent A comes back and says, I found a log entry that proves it's the database, Agent B might jump in and say, actually, that log entry is a symptom, not the root cause, because I found this network packet capture over here that shows.
That is incredible. It basically removes the human confirmation bias from debugging. You're not looking for what you think is the answer. You're letting the evidence fight it out in a structured way.
It's the scientific method, but accelerated and automated. But again, notice the cost implication. You are paying for 3 agents, 2 of whom will ultimately be wrong. You are paying for waste in order to buy speed and certainty.
That's a huge mindset shift. We're so used to AI being cheap or free. Paying for wrong answers feels totally counterintuitive, even if it gets you to the right answer faster in the end.
Welcome to management. You pay a lot of salaries for ideas that don't pan out.
Touché. Okay, so we have these massive brains and we have teams of them coordinating. But let's talk about the actual coding capability of a single instance. I keep seeing this term vibe coding popping up on Twitter and in the tech blogs. It sounds like something Gen Z came up with on TikTok. No thoughts, just vibes. What is vibe coding versus actual, engineering?
It is a fascinating cultural shift in the developer community, and it's being driven specifically by the capabilities of models like Opus 4.6. Vibe coding is the idea that you no longer need to write the strict syntax or worry about every line of boilerplate. You provide the vibe, the high-level, aspirational, sometimes even emotional intent, and the AI fills in all the implementation details.
Okay, give me a concrete example. What does a vibe coding prompt actually look like?
Okay, a traditional engineer prompt would be something like, write a React component using Tailwind CSS that displays a user profile card. It needs to accept username, avatar, and bio as props. The avatar image should be 64 by 64 pixels and have a fully rounded border.
Very specific, very detailed, very boring.
Exactly. A vibe prompt is, hey, I want a dashboard that feels like the inside of a Cybertruck, but mixed with a 1980s Bloomberg terminal. Make it track my crypto portfolio. I want it to feel aggressive and high contrast, maybe with some retro CRT scanline effects.
And the AI, it understands that. It knows what a Cybertruck vibe is.
Opus 4.6 does. This is why analysts have started calling it a product engineer persona. It excels at taking that vague, fuzzy human requirement, the vibe, and inferring the necessary schema, the CSS styles, the component layout, and the application logic to make it real. It builds a working prototype that matches the feeling you asked for.
So it's not just a coder, it's a creative partner. It's the architect who gets the vision.
Yes. But let's compare that to the competition for a second, because the sources we looked at are very clear on this distinction. We have Opus 4.6 on one hand, and we have OpenAI's latest GPT 5.3 codex, which launched around the same time.
Right.
And the consensus seems to be that while Opus is the product engineer or the architect, GPT 5.3 codex is more like the principal engineer.
What's the functional difference there? An architect versus a principal engineer.
The principal engineer is the one who comes in and reviews the architect's grand vision. They find the edge cases, they harden the security, they optimize the database queries, they make sure the beautiful design doesn't crash under a million users.
So they're the pragmatist.
Yes.
The one who makes it real and reliable.
Exactly. The benchmarks show that Codex is faster, about 25% faster, according to the initial reports, and it's better at what we call interactive collaboration, that back and forth refinement. But Opus is better at the greenfield work, creating something beautiful and functional from absolutely nothing.
So to put it in startup terms, if I'm building my first MVP from scratch, I want Opus to build it because it gets the vibe. But if I'm scaling that startup to 1 million users, I might want Codex to review the pull requests and make sure I didn't leave a password hard-coded in the source code.
That is a very, very sound strategy. And the benchmarks really back this up. On SW Bench Verified, which is pretty much the gold standard for testing an AI's ability to solve real-world GitHub issues, Opus 4.6 scores an 80.8%.
Let's pause on SW Bench for a second, because I think listeners might hear benchmark and they think multiple choice test. What exactly is SWE Bench testing?
SW Bench is literally a curated collection of real issues from real popular open source repositories on GitHub. An issue might be, this data visualization library crashes when you try to input a negative number.
A real bug that a real developer had to fix.
Yes. The AI is given the entire codebase and that bug report, and its job is to autonomously write a patch or pull request that fixes the bug without breaking anything else.
So it's literally doing the day-to-day job of a software engineer.
Yes. And an 80.8% score means it successfully solves 8 out of 10 of these real-world problems. For context, the previous state-of-the-art models were hovering in the high 50s just a year ago.
That is a massive, massive leap. But you mentioned earlier that Opus is the product engineer and it gets the vibe. Does that sometimes mean it?
Well, it improvises a little too much.
Ah, yes. The double-edged sword of creativity. Opus has what the engineers are calling higher variance.
Higher variance. That sounds like a very polite corporate way of saying it goes rogue sometimes.
It can. It means it's more creative, but also less predictable. Sometimes, in its zealous pursuit of the vibe, it might take liberties you didn't intend. It might hallucinate a feature you didn't ask for because it thought it fit the theme. Or it might decide to refactor a big chunk of your code that didn't need refactoring, just because it thought it could make it cleaner.
So it's the brilliant but eccentric genius employee that you love having on the team, but you also have to keep a close eye on.
Exactly. It needs monitoring. It's not a fire-and-forget robot you blindly trust. It's a powerful colleague you collaborate with. And that brings us perfectly to the next segment. Trust? and enterprise readiness. Because if we are going to use this in big companies, in finance and law, we can't have eccentric geniuses rewriting the back end of a banking app just because they felt like it.
No, the compliance department would have a heart attack.
Right. So the sources mention a very tight partnership with Microsoft Foundry. What is that about, and why is it so important?
This is absolutely crucial for the adoption curve. Microsoft Foundry is basically the adult supervision layer for enterprise AI. By embedding Opus 4.6 inside the Foundry platform, Microsoft is wrapping it in all the governance, security, and compliance protocols that large companies demand.
Governance. That's a word that usually puts people to sleep, but I have a feeling it's the only reason a Fortune 500 company would even consider touching this technology.
100%. Governance means answering the hard questions. Who has access to this model? Is our proprietary data being used to train it? Is the data leaving our geographic servers? Foundry provides the framework to ensure the answers are only these people, absolutely not, and no.
It puts a fence around the genius.
It does. And it connects with your existing corporate data through tools like M365, WorkIQ, and FabricIQ.
Okay, too many IQs. What do those do in plain English?
They ground the AI in your company's specific truth. M365 WorkIQ means the AI has secure, read-only access to your organization's emails, your team's chats, your SharePoint documents. FabricIQ means it knows about your data lakes and your internal SQL databases.
So it's not just a smart brain in a jar anymore. It's a smart brain that has securely read your company's diary and its bank statements.
Correct. And this unlocks use cases that are less about vibes and more about pure analytical grind. Let's take financial analysis.
Okay, walk me through a real-world scenario there.
Imagine you're an investment banker or a hedge fund analyst. You need to understand why a particular company's stock dipped unexpectedly back in 2022.
A common and very hard question to answer.
Right. That 1 million token context window we talked about, this is where it absolutely shines. You feed Opus a decade's worth of the company's 10K and 10Q filings, all their quarterly earnings called transcripts, and a folder of analyst reports.
That's thousands upon thousands of pages of the most boring, dense financial text imaginable.
Exactly. And because of that high recall we discussed, that 76% score on the needle in a haystack test, it can actually connect the dots across all those years. It can come back and say, the stock dipped in Q3 2022 because of a supply chain diversification decision mentioned on page 87 of the 2018 10K, which finally impacted their gross margins 4 years later.
That is the kind of deep synthesis that would usually take a team of human analysts days or even weeks of painstaking reading.
And it's doing it in minutes. And it's not just finance. Legal work is another huge area.
On
On the big law bench, which tests complex legal reasoning, Opus 4.6 scored an impressive 90.2%.
90% on legal reasoning.
It effectively acts as a senior paralegal or a junior associate. It can navigate incredibly complex contracts, select the right clauses from a template library based on conditional logic, like, if the client is based in California, use this indemnity clause, but if they're in New York, use that one.
That alone would save so many hours.
And it can spot potential liabilities or conflicting terms across a whole suite of documents. It's a huge force multiplier for legal teams.
It's also terrifying for the traditional billable hour model.
Or it's a massive relief for lawyers who are tired of spending 80% of their time reviewing boilerplate contracts. But let's go back to the cost for a moment. We talked about the $20,000 compiler. If a bank starts using this for every single document review, are they going to go bankrupt just paying for tokens?
That's the catch, isn't it? The smarter it is, the more expensive it is.
Anthropic realized this was a major barrier, so they introduced a really clever feature in the API called adaptive thinking, which is controlled by a new effort control parameter.
Adaptive thinking. Is that like the AI deciding when it needs to pay close attention and when it can just coast?
That's a great way to think about it. Think of it like a student taking a test. If a question is, what is 2 plus 2? You don't need to sit there, stroke your chin, and ponder the philosophical nature of mathematics. You just answer 4. That's low effort.
Right. So quick reflex doesn't require deep thought.
Exactly. But if the question is, design a sustainable economic model for a self-sufficient Mars colony, you need to sit back, plan, outline, draft, and revise. That's high or max effort.
So the model itself decides how hard it needs to think about my prompt.
Yes. The API now has this feature where the model performs a quick classification on the complexity of the task before it starts working. If it classifies the task as simple text extraction like find the customer's name in this email, it uses low effort. It's cheap, it's fast, and the answer is good enough.
And if I ask it to architect a new cloud backend for my application,
It automatically ramps itself up to max effort. It engages that deep chain of thought reasoning. It costs more, it takes a little longer, but the quality of the output is significantly higher.
That is incredibly smart from a business perspective. It's like an automatic transmission for your AI budget. You don't have to rely on your employees to manually shift gears and pick the cheapest model. The system just knows when to sprint and when to cruise.
And for a large enterprise, that kind of automated cost optimization is absolutely essential. You can't rely on thousands of employees to always remember to select the cheapest model setting. You need the system to manage itself.
So we've covered the coders and the corporate suits. What about the creatives? The writers, the researchers, the content creators. I see a note here about 128K output tokens. We've talked a lot about input reading 1 million tokens, but outputting 128K, what does that mean in practice?
This is a subtle but massive change for anyone doing long-form content creation. Most models we've used historically had output limits of 4,000, maybe 8,000 tokens if you were lucky.
Right. I've run into this a million times. I ask it to write a short story, and it cuts off mid-sentence in the beginning of chapter 2. Then I have to type continue, and it usually forgets the tone or the plot threads it just established.
Exactly. It completely loses the thread. An output of 128,000 tokens is roughly 100,000 words. That is a novel. That is a full-length nonfiction book. That is a comprehensive software documentation suite.
So you're saying I could give it a prompt like, write a complete 300-page mystery novel set in 1920s Paris with these 3 main characters and this central plot twist, and it could do the whole thing, start to finish, in one single coherent generation.
Technically, yes.
Yeah.
It has a large enough buffer to maintain the plot arc, the character development, the foreshadowing, and the pacing over the course of an entire book without stopping and asking you to say, continue.
That is wild. And probably a little depressing for aspiring authors.
Well, it's a tool, right? But let's look at it from a research perspective. There's another benchmark called BrowseComp.
BrowseComp. I assume from the name that's about browsing the web.
Yes. It measures the model's ability to find hard-to-locate information online. It's not just about Googling and pulling the top result from Wikipedia. It's about digging deep. It's about following a trail of links, synthesizing information from obscure academic PDFs, and cross-referencing sources. Opus 4.6 scores highest on this.
It's a real deep diver.
Like us.
Ideally, yes. And it integrates this research capability into the tools we actually use every day. We have to talk about Claude and Excel and PowerPoint.
Oh, right. I feel like AI in Excel has been promised for a decade now. What's actually different this time?
The difference is the agentic nature of the integration. It's not just a fancy formula helper anymore. You can give it a completely unstructured data set, say, a messy text file with a dump of sales emails, and it can infer the structure, clean it up, extract the key entities, and update a financial model in your Excel sheet.
So you can turn chaos into a clean spreadsheet.
And it can even pull in real-time data via what they call MCP connectors to services like Moody's or S&P Global, so your models are always up to date.
And PowerPoint. Please tell me it doesn't just make those generic, weirdly formatted slides with the terrible robot clip art.
The big claim here is that it generates editable slides. It can respect your company's corporate template with your fonts and your logos. It takes that Excel model you just updated and turns it into a 20-slide deck that actually looks like a human consultant made it.
That is the dream right there.
Yeah.
The death of the death by PowerPoint era.
We can certainly hope.
So Opus 4.6 sounds like an absolute beast. But it's not the only player in this town. You mentioned Gemini and GPT 5.3 earlier. If I'm a listener trying to figure out which subscription to buy or which API to use for my project, how do I choose? Let's do a quick head-to-head.
Okay, let's start with Opus 4.6 versus Gemini 3 Pro.
Gemini. What is its unique superpower?
Modality. Gemini is native multimodal. It can watch video and listen to audio files directly.
Meaning I can just upload a 2-hour video file of a lecture and say, give me the key takeaways.
Exactly. Claude is still primarily text and image only. It can't watch a video file. You'd have to transcribe it to text first. Gemini just watches it. Also, and this is a big one, Gemini is significantly cheaper. It's about $2 per $1 million input tokens.
And what's Claude again?
Claude Opus 4.6 starts at $5 per $1 million input tokens. So Gemini is less than half the price for ingestion.
So if my work involves hours of video footage, or if I'm on a very tight budget, Gemini is the clear play. It's the eyes and ears of the AI world.
Correct. But Claude is the brain. If you need that deep, long context reasoning on a massive text summary or complex multi-step instruction following, Claude still wins.
Okay, now what about Opus versus GPT 5.3 Codex?
GPT 5.3 Codex is the hands and the reflexes.
Yeah.
It's faster, about 25% faster than its predecessor, and it's much better at UI navigation. There's a benchmark called Osworld, which tests how well an AI can actually control a computer like clicking buttons, navigating websites, and filling out forms. GPT 5.3 is very strong there.
So if I want to build an agent that can go to a travel website, click around, and book a flight for me, GPT might be the better choice.
Potentially, yes. It's also better at that rapid, interactive back-and-forth coding we discussed earlier. It's the principal engineer reviewing your work line by line in real time.
But for the deep, long horizon, autonomous planning,
That is Opus territory, the deep thinking, the agent teams. If you have a complex problem that requires an hour of autonomous work and deep architectural decisions, Opus 4.6 is currently the undisputed king of the hill.
And what about the pricing on Opus? You mentioned it starts at $5 for input. Is there a catch?
There is a big catch, and it's tied to that amazing context window. We talked about how great 1 million tokens is. But if you actually go over 200,000 tokens in your prompt, which is where the real magic happens for those big books and code bases, the price doubles.
Doubles. So it goes to $10 per million dollars for input.
Yes, $10 for input and a whopping $37.50 for output.
Ouch. So that incredible recall capability comes at a steep premium. You are literally paying for the memory.
You are. Processing that much information and keeping it all active in memory is an incredibly computationally expensive task. There's also a new fast mode for Opus, which they claim is 2.5 times faster, but that costs significantly more. We're talking $30 for input and $150 for output.
Whoa, okay. So that's not for everyday use.
Yeah.
That is for when you need genius-level answers right now. Like for high-frequency trading algorithms or emergency cybersecurity response.
Exactly. Situations where every second is worth thousands of dollars.
Okay, so let's zoom all the way out. We have covered the specs, the agent teams, the coding paradigms, the business use cases, and the rivals. When I step back and look at the whole picture of Opus 4.6, the one idea that really sticks with me is this concept of orchestration.
That is the key word, orchestration. We are fundamentally moving away from prompt engineering. We spent the last 3 years learning how to write the perfect magic sentence to get the bot to do what we want, act as a marketing expert from the 1950s and all that.
I have a whole document full of those terms, my prompt library.
We all do. But with agent teams and these massive context windows, the skill of the future isn't prompt engineering anymore. It's team orchestration. It's vibe setting.
Vibe setting. That brings us right back to that concept from the beginning.
Yes. Your job as the human is to set the high-level intent. Build a C compiler that is compliant with this specific standard. Or analyze these 10 years of financial data and find the 3 hidden risks that nobody else has spotted. You set the goal, you define the quality standards, and then you unleash a team of synthetic agents to execute on that vision.
It really does sound like we are all becoming managers.
We are. We're moving up the value chain. And that raises a final, pretty provocative question.
Which is?
If an AI can spin up 16 versions of itself to write a compiler, and if it can debate its own hypotheses to find the truth in a bug hunt, and if it can self-correct and update its own plans without your intervention, at what point does the human manager become the bottleneck in the loop?
That is a little terrifying. It implies that we need to be faster or smarter or just different to keep up.
Or it's liberating. It depends on how you look at it, right? If the AI is the team that handles the how, you get to focus entirely on being the visionary who defines the what and the why. But you have to actually have a vision. You can't just be a taskmaster anymore. The tasks are being solved. The vision is what's left for us.
That is a powerful thought to leave our listeners with. The tools are getting infinitely sharper, so we need to get crystal clear on what it is we're actually trying to build.
Precisely.
So, to everyone listening, here is my challenge to you. If you had 1 million tokens of context, basically an entire library in your pocket, and a team of 5 expert agents ready to work for you 24/7, what project would you finally tackle? What is the vibe you would code into reality?
I would love to see what people come up with. That's an exciting thought.
Me too. As always, thanks for taking this deep dive with us. We'll catch you on the next one.